Hello, greetings to everyone. Our topic is pharmaceutical incompatibilities. Subtopic is chemical and therapeutic incompatibility, which is presented by Majid Unissa, Saleha Kauser, and J. Kiran. First, let us begin with the introduction of pharmaceutical incompatibility. Now, let us understand the term incompatibility. It refers to the interaction between two or more substances that result in change in physical, chemical, and therapeutic properties. When these incompatibilities arises in pharmaceutical dosage form, they are known as pharmaceutical incompatibilities. Why we are giving so much of preference to pharmaceutical incompatibility? Is it really necessary to know about these pharmaceutical incompatibilities? Yes, because it affects its safety, efficacy, appearance, and stability of pharmaceutical products. Now, moving ahead to types of pharmaceutical incompatibilities. Majorly, there are three types of pharmaceutical incompatibilities. They are: first one is physical incompatibility, second one is chemical incompatibility, and the third one is therapeutic incompatibility. Physical incompatibility. As the name indicates, when two or more substances are combined, a physical change occurs, such a change in appearance, odor, texture, and morphology. The next one is chemical incompatibility. When two or more substances are combined, a chemical change takes place. This is known as chemical incompatibility. The last one is therapeutic incompatibility. When two or more drugs are concurrently administered, an unintentional change occurs, causes therapeutic incompatibility. Now, moving ahead to our subtopic, which is chemical and therapeutic incompatibility with examples. We are going in detail about chemical and therapeutic incompatibility. So, let's begin with it. The first one is chemical incompatibilities. It refers to change in chemical properties of pharmaceutical dosage form as a result of reaction between two or more substances. Types of chemical reactions generally observed are as follows: oxidation, isomerization, absorption of carbon dioxide, hydrolysis, formation of insoluble complexes, polymerization, and decarboxylation. Now, types of chemical incompatibilities. They are divided into two types based on their chemical interactions. They are: first one is tolerated incompatibility and the second one is adjusted incompatibility. Now let us see what are they. In tolerated incompatibility, generally the chemical interactions are minimized by changing order of mixing, as the order of mixing plays an important role while dispensing a formulation or the solution is diluted, but no alterations is made to the dosage form. Hence, it can be tolerated. Now, adjusted incompatibility. In this, the chemical interactions are prevented by adjusting either through addition or substitution. Addition and substitution is done by replacing one reacting ingredient with another one of equal therapeutic value. Next few slides contains examples of chemical incompatibilities. The first one is strychnine hydrochloride mixture. The prescription contains strychnine hydrochloride solution of quantity 6 ml, aromatic spirit of ammonia of 4 ml, and water up to 120 ml. Result: strychnine hydrochloride is an alkaloidal salt, whereas aromatic spirit of ammonia is an alkaline substance. When they react together, the strychnine gets precipitated because the quantity of strychnine hydrochloride prescribed in the prescription is much more than its solubility. The aromatic spirit of ammonia contains negligible amount of alcohol. So to overcome the diffusible precipitate, a method is followed, and this method is method A. The method has following steps. The first is divide the vehicle, that is water, into two portions. Dissolve the reactants, i.e. strychnine hydrochloride and aromatic spirit of ammonia in separate portions and mix the two portions by slowly adding one into another with constant stirring. The another example is quinine hydrochloride mixture. The prescription contains quinine hydrochloride, which is of quantity 0.12 ml, sodium salicylate, which is of 4 gram, and water, which is of 100 ml. Result: when quinine hydrochloride combined with sodium salicylate, it forms quinine salicylate, which is an indiffusible precipitate. Remedy: to overcome this indiffusible precipitate, we follow a method, and this method is method B. It also has following steps. The first step is divide the vehicle water into two portions. Dissolve the one of the reacting substance quinine hydrochloride in water, that is one portion. Then place the second portion of vehicle in mortar and incorporate suitable amount of sodium salicylate and tragacanth powder with constant trituration until a smooth mucilage is produced. Add the solution of first reactant to the mucilage slowly with constant stirring. And the last example is menthol emulsion. The prescription contains phenol, which is of quantity 0.5 gram, menthol, which is of quantity 0.1 gram, tragacanth, which is of quantity 0.5 gram, olive oil, which is of 50 ml, and lime water, which is of 100 ml. Result: inverse of emulsion. As you can see in the picture, when the olive oil reacts with lime water, it forms water and oil emulsion, and when it reacts with tragacanth, it forms oil and water emulsion. Remedy: the prescription is referred back to the prescriber to replace either lime water with purified water or omit tragacanth. Now coming to the last topic, that is therapeutic incompatibilities. The therapeutic incompatibilities: in this, two drugs are administered concurrently, which alters their therapeutic effect by producing unintentional change in their pharmacokinetic and pharmacodynamic parameters. The causes of therapeutic incompatibilities are as follows. The first one is overdosing on a single drug. Using the wrong dosage form. The drug has contraindications, and drugs that work synergistically and antagonistically. The examples of therapeutic incompatibilities are as follows. Atropine sulfate capsule. The prescription is written as follows. Atropine sulfate, which is of quantity 0.005 grams, phenobarbital, which is of quantity 0.015 gram, and aspirin, which is of 0.300 gram. Causes overdosing. Overdosing of atropine sulfate, which is more than its recommended dose, that is 0.25 to 2 mg. As in the prescription, it is 0.05 gram, so overdosing occurs. The remedy: the prescription should be referred back to the prescriber to correct the overdose of atropine sulfate. The another example is sulfadiazine capsule. The prescription is written over here is sulfadiazine, which is of quantity 250 mg, sulfamerazine, which is of quantity 250 mg, and ammonium chloride, which is of 500 mg. The cause is contraindication due to the combination of sulfonamides with ammonium chloride. The general side effects of sulfonamides is crystal urea, which gets eliminated normally. But when it is combined with ammonium chloride, the ammonium chloride causes deposition of this crystal in kidney, causing renal disorder. So, the doctors must be very careful before prescribing such combinations, and pharmacists should notice such errors and refer it back to the prescriber. The last example of therapeutic incompatibility is amphetamine and ephedrine sulfate syrup. The prescription is as follows. Amphetamine sulfate, which is of quantity 20 mg. Ephedrine sulfate, which is of quantity 100 mg. This is a sympathomimetic syrup. The effect is synergism and antagonism due to the combination of dosage form. The remedy is the dose of this combination should be reduced. Now, questions time. Now we will ask some questions. You have 15 seconds to test your knowledge and give 10 marks to yourself for each right answer. If you guessed it right, then give yourself 10 marks. Now let us begin with our first question, that is, changes in color, texture, odor and viscosity represents which type of incompatibility? The options are A. Chemical incompatibility, B. Physical incompatibility, C. Therapeutic incompatibility, and D. Pharmacological incompatibility. Let's wait for 15 seconds to answer. And the answer is physical incompatibility. Next question. Which type of chemical changes are observed during chemical incompatibility? And the options are A. Evaporation, B. Sublimation, C. Oxidation, and D. Dissolution. And the answer is C. Oxidation. Next question is, chemical incompatibilities can be identified through naked eyes by observing which type of parameters? The options are A. Precipitation, B. Thickening, C. Turbidity, D. All of the above. And the answer is all of the above. Next question is, drugs containing amino acid cannot be taken with monothioglyrol oxidase inhibitors represents which type of incompatibility? And the options are A. Chemical incompatibility, B. Physical incompatibility, C. Therapeutic incompatibility, and D. None of the above. And the answer is C. Therapeutic incompatibility. The next question is, which incompatibility can be corrected by changing the order of mixing? The options are A. Intentional, B. Unintentional, C. Tolerated, D. Adjusted. And the answer is C. Tolerated. The next question is, in therapeutic incompatibility, if the amount of drug is more, then what should be done? A. The quantities should be adjusted. B. It should be diluted. C. The prescription should be returned back to the prescriber. D. None of the above. And the answer is the prescription should be returned back to the prescriber. Now, calculate your score. I hope you liked our video. We are waiting for your feedback. Thank you.